Hello everyone, I'm Priyanka Shah and welcome to my channel Mathelite. In this video, I'll be giving you an introduction to irrational numbers. So let us consider a few examples to understand what are irrational numbers. I have written down roots of some numbers over here. So let us try to find the values of these roots. So coming to the first one, root of 1. Square root of 1 is 1. Square root of 2. Square root of 2 ka if you try to find the value, you are not going to get some exact value. Okay, so let me write down not an exact value. And similar case with root 3. So let me write down not an exact value. Root of 4. Square root of 4 is 2. Square root of 9 is 3. Square root of 25 is 5. Cube root of 3. Again, I am not getting an exact value. So, I'll write down not an exact value. Cube root of 64. It is 4. Cube root of 125. It gives 5. Fourth root of 16. It is 2. Fourth root of 256. It will give 4. Fourth root of 700. Again over here, if I try to find the value, factorize karungi, so I'll not get an exact value. So not an exact value. Now I'll consider these 4 examples जहाँ पे मुझे exact value नहीं मिल रहा है. जब भी a square root of a rational number does not give you an exact value, it means it is an irrational number. So basically, root of a rational number, be it square root, cube root, fourth root, fifth root, if you are not getting an exact value, exact number, then it is an irrational number. The root of that number is an irrational number. So root 3, root 2, cube root of 3 and fourth root of 700 are irrational numbers. Okay, let us consider the 4 examples that we were trying to find the values of and we were not getting an exact value. So I've written down the values of these roots over here. Let us try to understand them in detail, that is, try to understand irrational numbers in detail. So considering the first number, root of 2, 1.41421356237 ... that is, the number is non-terminating. All the numbers you see over here are non-terminating. Okay, कोई भी end नहीं हो रहा है. So all these numbers are non-terminating. Now, are they repeating or recurring? 4 repeat हो रहा है, but is it following some pattern? Like in repeating numbers or recurring numbers, we had a pattern of the numbers which were repeating in a certain manner. Can you see some manner over here in which they are repeating? 7 तो अचानक से यहाँ पे आ गया. There is no some pattern over here. Same over here. There is no pattern being followed over here. So there is no definite pattern in which the numbers are repeating. So what I can say over here is that the numbers are non-repeating or non-recurring. So the numbers are non-terminating as well as non-repeating, that is non-recurring. So they are non-terminating and non-recurring. This means that irrational numbers are non-terminating and non-recurring numbers. They do not follow any definite pattern and they are non-ending. Alright? Considering the last example, pi. Okay, pi that we use in calculating areas, volumes, finding circumference. So this pi is actually, we consider a rounded off value, right? But the exact value is non-ending. It is an irrational number. It is non-terminating. It is non-recurring. So pi, always keep in mind, is an irrational number. Yes, we do round off pi as 22/7, but pi is actually not exactly equal to 22 upon 7. It is just a rounded off number, because if you consider 22 upon 7, it is a rational number because ये एक fraction है which is of the form p upon q, where q is not equal to 0. Okay, so this is basically a rational number, but pi is an irrational number. Let us consider two more examples to get clear with the concept of rational and irrational numbers. Now I've considered roots of two numbers once again, root of 0.04 and root of 6.25. The answers of these two roots are in decimal form. Okay, but if you observe, these two are terminating decimals. Now, terminating decimals are rational numbers. So, if the root of a rational number is giving you a decimal number as an answer, but the decimal is a terminating decimal or a recurring decimal, then the root of that number is said to be a rational number. But if the root of a rational number is giving you a non-terminating as well as non-recurring or non-repeating number, then the root of the rational number is said to be an irrational number. The root of that number is an irrational number. Coming to the last part of the introduction of the chapter, set of rational numbers is denoted by capital letter Q as shown over here, and set of irrational numbers is denoted by Q prime.